method. Okay, so what we were doing should kind of make sense. We were adding up areas of rectangles. And if we want to get the true area, then the number of rectangles has to go to infinity. So that's why we kind of started there with that idea of adding up areas of rectangles. But there is a way to do this that actually gives us the equivalent answers. With it, we have a couple properties of integrals. So the integral from a to b, if you wanted to flip it and go from, this was b to a. If you wanted to flip it and go from a to b, all that happens is you put a negative in front. So for instance, if I'm finding the area from, let's say, 0 to 4, all right? That's the opposite of the area if you came backwards, starting at 4 and backing up. All right, so you can flip those limits, it just puts a negative in front of the integral. This one, the limit from a to a of f of x is equal to 0. All right, so for instance, in this one, if I said I were doing the limit from 2 to 2. All right, we've talked about this limit, it's really giving us the area under the curve, but the area, if I start and stop here, do I have anything to calculate the area of? No, there are no rectangles that fit because I didn't go anywhere. So if those limits are the same, it's just an automatic 0. All right, the next slide. This is the big piece for today. So if g is the antiderivative, then this integral is really equal to the antiderivative of at b minus the antiderivative at a. Here's what that means. If I asked you to do this integral, yesterday we would have found our change in x, 3 over n, x sub I, 3 over ni. Then we would have plugged that in and set it at the limit of the sum. Now I'm telling you, what is the antiderivative of x squared? 1/3. Okay. Technically, we have the plus c on that, right? That's what we were taught. We are going to evaluate this from 0 to 3. Okay, before we just did generic antiderivatives, we didn't have any limits on those. But now we do. So what this means is you plug in the top. So if I put in the top one, and we're going to subtract what we get when we plug in the bottom one. Okay. So 3 cubed is 27 times 1/3 is 9. So I get 9 plus c minus c, which is just 9. Now, on every one of these problems, what's going to happen with this c? Every time you're going to have it in the first, and then you're going to subtract it from the second one. So every single time, it cancels out. That means if we have what's called a definite integral, so when we have numbers to plug in, you actually don't have to include the plus c. You can, it subtracts off, but there's really no need because we know it's going to disappear. Okay, so we have to have the plus c if we don't have any numbers to plug in. If we do have numbers, we can drop the plus c. This is the same thing we would have gotten. Did we do this exact problem before? Maybe we did, but I don't remember. If I'd worked it out, let me just prove to you. You don't have to write this down. So I already said the change in x was 3 over n. So our x sub I was 0 plus 3 over ni. So if we had done it like yesterday, the limit, number of rectangles goes to infinity. The sum from 1 to n, f of x sub I, so it would be 3 over ni cubed, or no, it was squared, wasn't it? original function? X squared and then dx is our 3 over n. So if I had done this like yesterday, we get 9 times 3, so 27 over n cubed I squared. Our I squared formula, n times n plus 1 times 2n plus 1 over 6. Okay. Reduce. So if I work that all out, I get 9 plus 27 over 2n plus 9 over 2n squared, and as the limit goes to infinity, we just get 9. Same answer, but which way's faster? Definitely the first one. Way, way faster. Okay, so now we have this shortcut. So if I ask you to find this one, all right, I have a lot of variables here, so I'm not going to get just a number answer. But we have to do the antiderivative of this x to the n. We know the antiderivative adds 1 to the exponent. So what has to go in front of this? Since I have things to plug in, I don't need a plus c. We're just going to evaluate from a to b. Because this was a dx, that tells me the a and b are going in for my x. So I have 1 over n plus 1 e to the n plus 1 minus 1 over n plus 1 a to the n plus 1. Right, this would have been an extremely difficult problem to work yesterday because I didn't have any actual numbers. But today we can get it really fast. All right, let's look at this one. The integral from 0 to pi of sine x dx. What is the antiderivative of sine? What has a derivative of sine? Don't have to include the plus c. All right, you are welcome to, like any coefficients, if you want to just pull that negative out for a moment, you can. You could just do negative in front, then cosine of pi minus cosine of 0 if you want. Cosine of pi, I think cosine is the x, so cosine of pi is -1. Cosine of 0 is 1. So I get the opposite of -2 or +2. Look at this. We would still be on our first problem. All right, I want you guys to try the next one. So what's the antiderivative of x to the 5th? So if you want, you can just pull the 1/6 out for now. Put in your 2. 2 to the 6th is 64. Minus 0 to the 6th is 0. So I get 64 over 6, or 32 over 3, or that's like 10.6 repeating. All right, how do we do with that one? All right, so we can do more complicated expressions. It doesn't have to just be a single term. We did antiderivatives of expressions that had multiple terms, and we know we just did one term at a time. So same thing is true here. So if I asked you to evaluate this integral, using our other strategy, this would have been a very long, complicated problem. But now it's fairly simple. We do the antiderivative of each term. So what is the antiderivative of 2x? Okay, right here. If we add 1 to the power, negative 1/2 plus 1 is 1/2. So what has to go in front? Reciprocal of 1/2. Minus the antiderivative of 3 would be 3x. And if you ever need to check your antiderivative, we know we just do the derivative of this expression and make sure it gives us back the original. All right, so now I'm going to plug in my 9. And I'm going to subtract what I get when I plug in my 1. So 9 squared is 81. 9 to the 1/2, so square root of 9 is 3, times 2 is 6, minus 27. Over here I have 1 minus 2 minus 3. I get 52 for my final answer. Any questions there? Let's look at this one. So in doing antiderivatives, we can't do product or quotient rule in reverse. So if I have two things multiplied together, I have to multiply it out first. If I have things being divided, I figure out how to simplify it first. This one, if you were doing the derivative, it would be a chain rule problem, and sometimes we can do chain rule in reverse. I only have an x in one place, so this one should work out okay. The alternative would be, could you take 2x plus 1 and multiply it out 3 times? Absolutely. Think about the chain rule. When you did this, the exponent would come down, inside stays the same, subtract 1 from the power. So when we undo it, we know in the chain rule, the inside stays the same, so this is still 2x plus 1. We would have to add 1 back to our power, so that would give it a 4. So what would have to go in front? 1/4. All right, so chain rule, bless you. 4 comes down, so those cancel. Inside stays the same, subtract 1 from the power. But then I would have to do times the derivative of the inside. What's the derivative of the inside? 2. So what do I need to cancel that? Okay, so my antiderivative is actually 1/8 times 2x plus 1 to the 4. Does everyone understand how I got there? So if you want, you can just pull the 1/8 out in front. If I put in my 1, I get 2 plus 1, so 3 to the 4th. Minus, if I put in my 0, 0 plus 1 is 1 to the 4th. That's 1/8, 81 minus 1. So 80 over 8. Gives me 10. Let's try a couple more together and then I'll have you guys. All right, sine of 2x. When you do the derivative of a trig function, the angle doesn't change. What has a derivative of sine? And when I do that, my angle can't change. But if I do this derivative, derivative of cosine is negative sine, inside stays the same, times the derivative of the inside, which is 2. So what do I need to cancel that? So it's a negative 1/2 cosine of 2x. And I'm evaluating from 0 to pi over 2. So if you want, you can take out that negative 1/2 for a moment while we plug in. If I put in pi over 2, 2 times pi over 2 is pi, minus 2 times 0 is 0. Cosine of pi, we already said in the last one, was negative 1. Cosine of 0 was 1. So negative 1/2 times negative 2 gives me 4. Any questions on that one? So this one, I can't just do the antiderivative of secant and the antiderivative of tangent, right? They're multiplied together. If I were going to do the derivative of things being multiplied, it's a product rule. But let's ask ourselves, do we know anything that has a derivative of secant x tangent x? What is it? The derivative of secant is secant tangent, so that's just my antiderivative. So secant of pi over 4 minus the secant of 0. So secant's reciprocal cosine. Cosine of pi over 4 is radical 2 over 2. So secant would be the reciprocal, or just the square root of 2. Cosine of 0 is 1, so reciprocal is 1. So we just get radical 2 minus 1. I want you guys to try this one. You remembered that a square root is just a 1/2 power. So when we do the antiderivative, inside will stay the same. Add 1 to the power, so that would be 3/2, which means there must be a 2/3 in front. But you also have to think, if you do this derivative, exponent comes down, inside stays the same, subtract 1 from the power, times derivative of the inside. The derivative of the inside is 3, so we need another 1/3 to cancel that. So we have 2/9. 3x plus 1 to the 3/2. And we're evaluating from 1 to 5. You can take the 2/9 out if you want. A 3/2 just means the square root of something cubed. So if I put in a 5, I get a 16. If I put in a 1, I get a 4. Square root of 16 is 4, to the 3rd is 64. Square root of 4 is 2, cubed is 8. So we get 2/9 times 56. So 112 over 9. Last one for the day. Suppose an animal population initially numbers 100 and that its rate of growth after t months is given by this equation. So that's our population growth. What is the population after 10 months? So we need to find, this is the rate, If you do the antiderivative of rate, you get the amount that our population grew. T is a number of months, so if I want 10, after 10 months, where should my integral start and stop? 0 to 10. And this would be dt, since t is my variable. All right, so antiderivative of 10 would be 10t. Antiderivative of t would be 1/2 t squared. Antiderivative of 0.06 t squared, so it'd be a t cubed, so divided by 3, so 0.02. So if I put in the 10,
Hey, sir? So
and I
that
get
triple that.
170. But this isn't my actual answer. I want my total population after 10 months. What does the 170 represent?
That's total population.
It's how much it grew.
Yeah.
How much did we start with?
Sure.
So we have to add our 100 back. We got the amount the population grew by. But if I want my total population, I have to add in the 100 we started with. So we end with 270. We added 170 to the population plus the 100 that was there. All right. Any questions there? We're stopping here for today. We'll pick